Then the book speaks about passing arrays as function arguments. When I pass an array, or when you pass an array, you're passing it by the name, right? Let's say I have a function that says display array, and I give it my array, right? I gave it my array. Here it is. This is my array. I'm gonna say this doesn't have to return anything, and it's called display array, and it takes an int array, and that's it. Then I define it, and I say, hey, you see the prototype declared above? Here is the body for it. It takes an int a array, a for argument, and now I'm here. See out, blah, blah, blah. When I receive this, I'm receiving the beginning address, right? When I receive the beginning address, this worker function, every function has a scope. So every function has access to whatever within the scope. Within this scope, I have the beginning address. So as a worker myself, let's say my mindset at this point is this. I am the worker function. I am a function that my responsibility is to display an array that I receive as an input. When I receive a beginning address, how do I know what's the size? There is no way I can tell what's the size. And the fact that an array allows out of the boundaries access, that means it's impossible to know the size unless the caller function or the boss function gives me the size. So the boss function or the caller function needs to display an array. It gives me the beginning address and it tells me, hey, this has 10 in it. Display only the first 10. The first 10 are what's assigned to me. So here, const int L size. Since it's const, we use capital case, capital letters. So size is 10. Then I replace size here, and this is the way you want to do it, because in this style, this coding standard, if I want to change the size, I only change it in one place. However, if I had it like before, like this, if I want to change the size, I need to go over all the lines of code and change them one by one. And imagine reading every line of code and checking, oh, does this need to change or not? No, you don't want to do that. What you want to do is something like this. You assign it once. As a matter of fact, you put it as a global variable. You put it as a global variable. This is the size, and everyone references it. If you want to change the size, or the requirement has changed, or someone asks you, your boss, your customer, to have a different size, then you change it in one place. So every time you need to pass an array, you need to pass the size with it. So the prototype has changed. Also, the definition needs to reflect the change. Now I'm good to go. As a worker function, I'm good to go. I have a where the memory block starts and how many I need to iterate. So now I can say, okay, for int I equals 0, I less than size. For each iteration, display I. Yeah, or there is a logic based, actually business requirement based logic, and it's called Sentinel. Sentinel is having a value at the end that indicates the end of the data. For example, business requirement or business requirement based logic means it depends on your program. What is your program trying to do? Then you can hack it or trick it in a way that indicates the end. For example, let's say these are my grades. My grades have size of, I don't know, 100. I'm not going to have a class, at least not in the near future. I'm not going to have a class that has more than 100 students. So 100 is enough. Then I'm going to say, okay, I declared an array, garbage array. Sorry. Garbage array. Then I'm gonna ask the user. So while L input is not -1. -1 is my sentinel. My sentinel based on my logic. The fact that the logic says that there is no grade that is -1, or maybe no grade above 100, also above 100 could be used. The fact that the logic or the business says this array is my grade, that means there is no way I can have a negative. So I can use the negative as a way to indicate the end of the data. For example, int L sentinel equals -1. Also, this could be global and const. So I can change it in one place. But anyway, then I have a L input from the user that is equals to 0 for now because I want to trigger the while loop. So I'm gonna say enter next grade. Then cn into L input. Now that I entered into CL input, if L input is not -1, then L my well, as a matter of fact, I don't care. I want my input, whatever it is, to be in my array. So I use it, then increment it at input. Now that I have this, I need I equals to 0, and we pass it here. Now that I have a sentinel, I no longer need to pass the size for a walker. Why? Because I know the sentinel. So I remove these, and I remove these. Now in my display data, I can say for or while true, right? Infinitely. Keep going until a array at I is not equal sentinel. If that is the case, then display a array. Oh, I can't do that here because I need it. And L. Then I plus plus. Once you use it, do it. So here, int I equals 0. So I'm gonna start from 0 as long as the value that I'm on is not -1, display it and keep going. So if I run now, what's my grade? Oh, first student scored 60. Next student scored 77, 90, 60. I can keep going, right, with numbers. I can keep going up to 100. Once I'm done, and I know I'm not gonna have more than 100. So once I'm done with all students, I can enter -1. Once I enter -1, this will break out. Then it's gonna display all the arrays. So if I put my breakpoint here, and then I hit, now it's gonna go on. So the fact that I'm in this scope, between this scope, when I hover my mouse, I do not see all the values. This function or this worker function has only access to an address that arrived from the outside. A boss function or a caller function called me as a worker function, called me and gave me a beginning address. I don't know where the end is, but I know that it ends at -1 based on the business. So I can say go on, and it will display everything until 35, until it reached the sentinel. See, it displayed all of them all the way. Oh, the function found -1, then don't display and stop, break out of the loop. It's no longer, there's no more data in it. So this is the topic for functions as arguments. Then they go over a two-dimensional array. Two-dimensional arrays, in general, 2 dimensions is very important because everything you see on a screen is 2-dimension. Any image you see is stored as 2-dimensional container. An image, any image, flowers, any flower, see, any flower you want to display, this is stored in memory. Here it is, stored as 2-dimension. You have height and you have width, and on each height you have a row of pixels, and on each row you have columns of pixels. So this here is 0 0 0 rows, 0 columns. Then the next one to the right is row number 0, column number 1. Then the next one is row number 0, column number 2. So 2-dimensional array. There is a topic on it because we are running a little out of time and I need to go a little quicker just because I noticed that you guys did homework 1 and project 1 very good. So this might be a little boring for you that I'm going into details. However, if you think I'm going too fast, stop me, stop me, reach out, ask questions. So I'm passing on 2-dimensional array. If you don't know 2-dimensional arrays, read the topic and then ask me questions. Then that also they go by arrays with 3 or more dimensional. So you have 2-dimensional arrays, you have 3-dimensional array in a 3D space, you have 3 dimensions, X, Y, Z, and you have more than 3 dimensions. You have containers of n dimensions. You never know. For example, in a factory warehouse, right, where let's say cases of juice are stacked on pallets, an array with 4 dimensions could be used to store bottle number or stack or pack of bottles for each pallet. So you have a warehouse, and that warehouse has aisles, and on each aisle you have like ground, then a shelf, then another shelf, then on each shelf you have pallets of bottles, and that pallet has one case, second case, third case. So how do you locate a case? You need an n dimension. Well, not an n, 1, 2, 3, 4 dimensions. That's 4 dimensions per warehouse. Now, if I have multiple warehouses, that's a 5th dimension. I need a container of 5 dimensions to represent all the bottles across all warehouses, right? You're going to have rows for which warehouse, a dimension for which warehouse, another dimension for which aisle, another dimension for which shelf, another dimension for which part of the shelf that piece is on. So moving on, then they introduce vector briefly. Vector fixed. So remember how I said arrays has a lot of disadvantages? So C++ introduced a new container that fixes all the disadvantage or provides a solution for all the disadvantages from arrays. They share a lot of common though. There are a lot of commons in between arrays and vectors. For example, the same way an array holds a sequence of values sequentially in memory, vectors also store values sequentially in memory. Also, a vector stores its elements in a same type. Similar to the array, you cannot store different data types in an array, similar to vectors are. You can only store, no matter how many items you need, but all the items need to be from the same data type. Also common is to access values or items in a vector, you use the square bracket, just like an array. However, the new things in a vector, and the things that vector offers over arrays are you don't have to have a memory, you don't have to have a size on compilation time. You can declare an empty vector And on runtime, change the size, add items to the vector. I can initialize a vector at the beginning with size 10, and during the runtime, I can change it to 15. I can add up to 20. I can add up to 1,000. I can also reduce it from 1,000 to 500. And vector under the hood will maintain the continuity of memory. Means if I start my program with size, let's say 5, with size 5, and on runtime I added items, vector will maintain the continuity. It will go and ask the operating system and maintains it under the hood. If you need more details, let me know. So there are code on how to declare and how to use vector, but it's the exact same like an array. Right now, they introduce only few methods that are important. For example, a size vector provides you the size method. You can just call a method called size. Hey, vector, give me the size, and the vector will return the size of its elements, how many items in it. So remember the hassle we had about passing an array to a different function or declaring with a fixed size. You don't have all that with a vector. You can just pass the vector and call a function that gives you the size and then iterate based on the size. As well, you can assign vector to another vector. Also, you have methods, list of methods that are on page 448. These are the main methods in vector. You have at, which is square bracket, clear, empty, pop back, push back, resize, and swap. These are the most important functions. And there should be erase. I don't see erase. Erase will, so pop back will remove the last item. Push back will append a new item. Erase takes a position and erases the item at that position. This is it for chapter 7.